Hi, my name is Shadi Atia, professor at Liège University in Belgium, and today I'm going to talk about a very important topic, research ethics. I've been doubting for long before preparing and presenting this presentation because it involves some of my experiences with plagiarism, but I think it's a very beneficial presentation to share with you my experience and to put you in the picture. Well, this presentation is part of a playlist on academic modules on my YouTube channel. I advise you to check previous videos and to subscribe to the channel if you are interested in such videos. Now, the audience of today's presentation are mainly postgraduates and scientists who are conducting or seeking to conduct research. And the fields that this study is related to are social sciences, life sciences, medical sciences, and natural sciences. So it's simply covering most of the fields of research and science, and it's also meant to mentors and supervisors. Moving to the objective of this presentation, research integrity lies at the heart of excellent science and scholarship, and therefore it's a very important topic, and everybody should be able to explain the basic principles and understand it and apply it in their practice. So the goal of today's presentation is number one, teach professional scientists the rules of rigorous research and integrity, and number two, make them avoid misconduct. So those are the two objectives of today's presentation. Now somebody will ask me why it's important to talk about research ethics. Well, research ethics are very important because they promote the aims of research and help expanding knowledge. Without them, knowledge will never advance. And it's very important to support values of collaborative work, mutual respect, fairness, because at the end of the day, we are scientists working in teams. It's not about individuals, it's about the collegiality or the teamwork and the collaboration. So if we respect each other and we value each other and make sure that there's fairness in our competition, we will make sure that we can produce very solid research and science discoveries. Also, it is important because ethics, they mean researchers can be held accountable for their actions. Do not forget that most of our research is funded by the state, so public taxpayers. If we are not aware enough and on the level of responsibility, taxpayers will start to doubt about what we do, and therefore we need to be accountable about everything we publish and every information we share with the general public community or with the scientific community. So this is also important. Also, research ethics ensure the public can trust research, a big problem in a digital age of information where there is an abundance of information. The public is easily distracted by a lot of publications and anti-science movements. So it's very important that we reclaim or assure this public trust, and this is the only way to do it, that we ourselves exercise on ourselves the best practices and to do a self-control when we conduct our research. So these are very important aspects that we need to look at, and also this will support the social and moral values that many people are based in their simply life. So these are very important aspects. Now, what will be the content of today's presentation? I will talk a lot about many topics. First of all, I will talk about plagiarism, how to respect credits and citation, data ownership and intellectual property, the bias and the conflict of interest, the credibility and legal protection during conducting experiments and observations, the use of animals, the use of humans, falsification and fabrication of data, and finally I'll come to the conclusion with some takeaway messages. So let's start with the introduction, the first part of this presentation. What are research ethics? Well, progress in science is based on trust, and this trust is the basic of science. When studies are published in peer-reviewed journals, the general public will assume that what is presented is representing the truth, it's true and accurate. So it's very important to assure that this is the truth. Many ethical rules and guidelines are put in place to ensure the trust of the public. And in this sense, research ethics will assure that. Professional institutions determine the rules and codes of ethics, and most of the time you will find review boards in institution on the national level or on the university level or even on a more specific level that will define what are the best practices regarding integrity and research ethics. But this is the positive side of things. On the negative side of things, there is a lot of research misconduct that is taking place in today's scientific community, including the data fabrication, including the no informed consent, the plagiarism, manipulating images, using data without permission, using information without consent, data falsification, using animals in a cruel way, using subject without informing them, without respecting their privacy, their anonymity, and so on. The non-disclosure of information related to the methods, to the data, also non-disclosure of information on the safety procedures, and so on. So there is a series of misconducts, and I'm not here talking in a condescending way. I will share with you just right away one of the examples that I made in myself that I am not proud of, and I consider myself guilty or mea culpa. So let's go to types of misconducts that are today traced through the scrutiny. Today, science in general is under scrutiny. We found frequent retractions of papers because we discover later on that the data was false, there was a fabrication, the reporting was not honest, the results were spoiled. So it happens, and in this sense the retractions are simply that your paper will be retracted if it's published, and later on we come to the conclusion that this work was not true. The editor or the journal will retract the paper, and the paper will not be anymore published. So this is a nightmare for anybody who is not working respecting the research ethics. Another important thing that is also on the rise, on the increase, corrigendums. Corrigendums means that you have a paper or a publication that is published, and then you need to correct some information that is wrong, or a violation or a misconduct. You need to correct it. I give you example, something I did myself, and I consider myself guilty, so I say always mea culpa in this sense, and I consider it a very important example that maybe you will learn from it. This is one of my papers I published in 2020 with other co-authors, and I was responsible for writing the introduction section, and I was looking to find a nice figure that represent the different variables regarding the phenomena I was talking about. And as you can see, this was the figure that I produced, and I simply mentioned in the figure caption, describe this figure. So this was in 2020. But in reality, there was another figure that I based my work on, which the figure on the left side, and as you can see, there is a very high resemblance, and from my side, I was at that time when I did this mistake or error, I was thinking that it's enough, I processed the image enough without needing to cite the author, especially that I told myself, yeah, I'm not in the result section, so I'm not falsification or falsifying a result or something, or making up a result. It's just the image, explanatory image. But even this is not true, because there was almost 30 to 40% part of the picture was almost copy pasted with slight retouche or modification from my side. So actually the original author of the figure contacted the journal and contacted us and asked us to rectify this mistake, and he said, you copied my work. Directly my reaction was that I recognized this mistake, and I contacted the editor and I contacted the author, and I told him it's my responsibility and I'm ready to fix it. So what I did, I had to submit a corrigendum, and in this sense I added, as you can see here in the corrigendum, just said based on the work of Kubilai 2018. So adding this simple wording was the corrigendum, and this is happening often and often, and therefore I'm sharing this presentation with you to make you more aware about the retractions and the corrigendums, and to make sure that you try your best to avoid them right away from the beginning. So this is an example of my work, so don't ever think that I'm condescending or I'm just telling you how to be ethically correct. I myself also did mistakes, and this is the purpose, to share my errors so that you can maybe learn from them or others can learn from them. Also, what can happen on the long term if you are if you are having a lot of misconduct with your research, you can be even banned from receiving funding or conducting research. Maybe funding agencies will blacklist you if you get discovered that you are somebody who is not credible and you are not maintaining your reputation. So this is a very important aspect. Also, you can be discharged from your job if you are working in academia or in any science lab because of the misconduct. So this brings us to a very important concept that is not so commonly explained in all culture, and we do not find a clear-cut definition for it, which is integrity. In this graph, I try to collect different wording in different languages. Maybe I made a mistake. If you find anything wrong regarding your language or it's missing, don't hesitate in the comments of the video to write the right word. But simply research integrity, research behaviors are research behaviors and ethics that adapt highest standards of professional and rigor and ensure the accuracy and truth of the research record in publications and elsewhere. So this is the technical definition of integrity. And integrity is something that you have always to keep in your work. It's associated with your self-pride, it's associated with your truth, worthiness, it's associated with honesty. So it's important to look at integrity from this side and always make sure that you are respecting or applying highest integrity values in your work. Well, when should I take care about integrity and why is it important in some moments to focus on? I have to adapt or comply with integrity requirement all the time. Integrity is a trait or not, it's a trait that it needs to be embedded in you. But when should I look at it, focus and give more attention? During the research design. When I am designing my research strategy and defining the different components of my studies in a logical way, then I need to address the integrity. When I'm looking at the problem definition, when I'm looking at the data collection, on my measurement protocol, on my analysis of the data, even of the management of data, how I will store my data, how I will protect the data, how I will make it anonymous enough, how I can go back to the subjects if I have an issue with a privacy breach, for example. So during the design or the research design of your project or of your paper, you need to address integrity and put it on your checklist as one of the elements that you have to make sure it is respected in all phases, execution and design. Now I'm going to move to one of the first misconducts that are commonly found and reported in the academic world, plagiarism. Well, before explaining what is plagiarism, I need to explain to you what is intellectual property. Well, intellectual property or IP is a category of property that includes intangible creations of the human intellect. And there are many types of intellectual property, and some countries recognize more than others. The most well-known types are copyrights, patents, trademarks, and trade secrets. And all these types of intellectual property, they are protected. But why is intellectual property so important, and why is it related to plagiarism? Well, intellectual property promotes innovation and creation of positive environment for social and economic progress. Today we could not be here where we are in the 21st century without the progress on arts and in science. And if we did not have a protection of these different good ideas of people behind them, we could never have managed to stabilize and benefit from these ideas and make sure that we will generate more and more ideas and assure that we will be productive, having a good well-being and a well quality of life in the world. So it's very important to look at intellectual property as part of the societal, environmental and economical and social progress. Now, what is plagiarism? Plagiarism is simply reporting someone else's work as one's own. Like I did, for example, with the image. I took the image, I modified 70% of it, and then I claimed that it is my work without citing the original. While simply if I just said that this work is inspired by or based on, or I contacted the author to ask him for consent or for permission, things would be much easier. So reporting someone else's work, it includes copying someone's idea published in a book, journal, conference, or internet. Also claiming to author a paper someone else wrote. This is also a very common issue that happens, that authors, they start in the beginning a collaboration without setting boundaries, without defining the responsibilities, and suddenly they end up disputing, and you find editors receiving emails telling some other author telling them that this is my paper, this was my idea. And because I am an editor of different journals, I receive a lot of these kind of emails, and it's very difficult to solve this conflict, and most of the time we ask the universities to go and resolve this problem. So also this is part of plagiarism, because people think that they can simply take others' work. Copying and pasting any content without citing the author or paragraphing the content, this is plagiarism. And as you can see in the graph, plagiarism is the biggest reason for research retractions. So simply this is considered as stolen ideas and papers. And I don't know how it is seen in your country, but as much as stealing an object or money or any materialistic element is forbidden and is ethically not correct, the same goes with ideas, thoughts, copyrights, patents, publications, and so on. So the intellectual property also covers the field of art, covers the field of ideas and thoughts, music, and different types of content. So it's very important to be aware about plagiarism and to respect the intellectual property and fully cite the work if you are going to base your work on others, because this gives credits to your work. This moves us directly to the following idea, which is credits and citations. Well, once I do give appropriate credits and citation, I can avoid the problem of plagiarism. There is no problem to be inspired by somebody else's work, but just you need to mention what they did and build on it. So credits and citations are very important, and I have a video on citations and bibliography. I advise you to have a look if you didn't see it before. And simply you have to properly to cite and reference sources when using someone else's idea. Very simple. Allow readers to know where was the original idea published and support your argument. So it's a way to validate your writing and proving that what you say is true. Also, it can help you to check your you have to check your institution's journal citation guidelines, because every institution might have its own citation style, citation protocol, methods of citation, the use of software and tool. Again, like I told you in the video, I talk about all these details. And just to give you an example of citation, this is a journal paper that we published, and you can see the number of citations that we have. This is a list that you find at the end of your manuscript, including all the references, and they are numbered. And as you can see, some of them are blue because they are cross referenced, meaning that they are recognized by the journal in another journal, and the ones are black are documents that are not accessible. Maybe they do not have a DOI or a URL, or they are not available online. So this is very important. Now, I talked about ISBN, DOI, URL. If you don't know what are these things, I advise you to have a look at the video on ISBN number, which is a very important video to give you an idea how to track and cite a document. Also, you have to look at the DOI number. This is more for digital objects that are on the web. So check both videos to have an idea and to make sure that you can cite properly any source that you are using in your work. Now I would like to move to another type of documents or types of information that needs to be cited and needs special attention, mainly photos, and especially photos for buildings and for photos for human beings also. Well, copyright laws applies to photos of buildings and architecture in most countries, at least in standardized countries. And in this sense, you find that architectural works are protected by copyright law. So if you are taking a picture of this building, this is the train station in Liège in Belgium, and it's designed by the architect Santiago Caltrava. Now, if you want to use this picture, you need to cite the architect and you need to cite myself because I took this picture. So actually, this is very important. But I need also, if I'm going to use this picture of this building in any commercial use, I need to contact the owner or the author of the building to get permission. So you see how it's getting complicated? So a picture for a building requires architect's name and requires the name of the photographer who took the picture. So very important to take into account. And if the picture is copyrighted, you are not allowed to include it without the permission of the owner of the picture. So it's very important to keep this into account. And let's go one step further. Human beings, you are not allowed to share or take pictures of human beings without their informed consent. This means that if you take a picture of somebody and you do not take or get the consent, you can be punished. This is an example for a recent court order in French celebrity magazine that had to pay for a homeless man 40,000 euros last year just because the photographer took the picture of the homeless man without his consent and the picture was in the magazine. So this is very important. You need always to obtain permission from the subject or producer to legally share the original or derived data, whether they are human subjects, whether they are buildings, and so on. It goes also for products and other types of intellectual property. So this is very important, and it is part on citation and referencing. Well, I would like to move to the next idea, which is very important in our lecture on research ethics: data ownership and intellectual property. Two important concepts. Intellectual property is simply the rights. Intellectual property rights are acquired over any work created or invented with the intellectual effort or an individual or entity. So this is important to take into account. This is the definition of intellectual property. Data ownership is also an important issue because research data can come in different forms. They are subject to intellectual property right, so a data set is considered as an intellectual property, and there are different legal jurisdictions that apply to the use of these data. The data can be copyrighted in the form of a copyright, it can be patented in the form of a patent, and as you can see, there is adopters of laws that are enforced in the world in green, and there is countries that signed on such agreement like India, but the rest of the world has no respect for the data ownership. So it's very important to make sure that you respect the data ownership. And it's very important when you start any project that you resolve the data ownership early on with the stakeholders as early as possible. It's very important when you do that. Also, data governance will be a very important topic with operational roles that needs to be addressed, because as you see in this pyramid developed by the University of South Wales in Australia, you can see that there is something called the data owner, there is something called the data creator, and not always the data creator is the data owner. If you are getting a project that is funded by an institution or by the state or whatever type of organization, the data that is collected during this project, the ownership refers to the funder and not to the researcher who conducted the research. So it's very important to avoid this conflict and early on define the ownership of data and define the creator of the data. And for sure there is also data executives, there is data stewards that they are more looking at the management, but the data ownership as a topic and is an issue in relation to intellectual property needs to be designed, considered before starting the project. Otherwise, later on, you will have a conflict. And today, the money or the gold in research is data sets. It's not about anything than having big data sets with many data points or observations to make sure that you can dig in and that you can analyze them and create meaningful insights, understandings, and discoveries. Now, data ownership To make sure that you are on the right track, obtain permission from the subject or producers or proprietary data to legally share the original or derived data, and contact your valorization officers at your institution and legal professionals to determine the data ownership during the project's life cycle. So during the initiation of the project, during the execution of the project, and when the project is finished, what can I do with the data? Who has access to the data? Who owns the data? Should this data continue on our database? Can we maintain it? Should we destroy it? What can we do with it? Can we revisit it later on and use the data set in another work? Is it an open access format or is it protected? And so on. So it's a very important issue: data ownership, data sets ownerships, and intellectual property. Now this is the end of this section. I move to point number 5, the bias and conflict of interest. Bias and conflict of interest is a very human issue or misconduct, and it's very difficult to explain. And unfortunately, if you were not educated in a young age about bias and conflict of interest, it will be very difficult that you become objective. And I see many of scientists and researchers, they fall in this mistake. They are so biased, they are so unable to take distance and relativate things, and they put themselves in situations where there's a conflict of interest. Now, bias in research can take place during a study design or conducting a study or reporting a study. And peer review, and also it can happen during the peer review and scientific publication. So bias is simply that you have an opinion or you have a preference or you have prejudices and you say it is like this regardless of facts, regardless of evidence, regardless of tangible information. So the bias can influence your research and you build up your hypotheses with a bias and ending up that it's not true, and then you start to force the data and force the information to confirm your hypothesis. Now, according to Lisa Barrow, a scientist, a famous scientist, she defined different bias problems. First of all, she talks about the bias in research agenda, so that some research labs, they are focusing on specific topics and they are tackling the topic from a specific angle and not taking into account other angles. For example, I was just yesterday in a jury and one of the researchers was only focused on the environmental impact of a phenomenon and totally neglecting the social impact and economical impact. This is a type of bias if you are insisting to only use environmental indicators, for example. So it's important to have meta research, including different criteria, different perspectives, to make sure that you have a 360 view to the problem. Also, unpublished studies. This can be also a problem. So in this sense, what you can do to avoid the bias, you can have protocol publication or trial registries. So if you are relying on a document that was not published, but it's so important to your work, and there is a risk that this document is biased, you can have a trial registry. So before you do the experiment, you publish your methodology, and by that you make sure that you will avoid the bias. Other type of bias problems or types of bias is the selective outcome reporting, that you select the most interesting outcomes of your analysis or your processing of data, and you just report the part that has a variance, while in fact you neglect the relative weight of other parameters, and actually you are kind of cutting or zooming in on part of your analysis, which is not true, because then you are magnifying one of your outcomes, which is not true. So the only way to make sure that you avoid this selective outcome reporting is to do pre-registries, and you also go for open access data. So you make sure that your data set is open access, it's published, and there is a lot of data sets, platforms that allow for that, and data sets, journals. Also, another problem is the bias in the methods. So you are using a method that is by default biased. And the only way to make sure that your methodology is not biased is to comply in your methodological approach with international standards. If you remember, there's a video I developed on research methods. If you just Google research methods on my channel, and this video talks a lot about the importance of coupling your methodology and making sure that it's complying with standards, preferably international standards, regional standards, or national standards, to make sure that your methodology is not biased and that you are following the systematical steps that are already well thought by experts to make sure that you are not missing out on very important steps. Also, we have different types of bias of analysis. Like I told you, that a statistician will take only the part of the data that has variance. They will cut the graph and focus where is variance, and then they will report it as significant or remarkable variance or change and report it as a discovery, while in reality, if you put it in the big picture and you respect the scale of your graph, you discover that the change is minimal or insignificant. So this kind of violation happens and biases, and the only way to avoid this type of bias in your data analysis is, again, open access, sharing your data, making sure it is accessible, and involving other statisticians, asking other statisticians to do the same test or use other tests for statistics to make sure that really there is a variance here and there is a significance and there is a remarkable discovery or change regarding whatever variance you are looking at. Another big problem is the bias interpretation or the presentation. This is a phenomenon called spin, simply that you will interpret your outcomes through the discussion in a way showing that this is very important what you found, but in reality it is not. And the spin phenomena is the use of specific reporting strategies to highlight that the treatment is beneficial or the intervention is beneficial despite a statistical non-significant difference for the primary outcome, or to distract the reader from statistically non-significant results. And this has happened a lot when you go into the discussion section, that authors will try to manipulate the wording and the text to take you in a direction and totally cover up on aspects that are important and do not talk about them. For example, the randomization, for example, the replication, for example, the control of your boundary variables or your boundary condition, or a reference condition. So this is very important to take into account, but it's still difficult. It requires very intelligent and very thorough editors when reading the discussion section, and they need to be experienced and they really need to take the time to understand what is said. Most of the time reviewers are having variance in the experience. It is not easy to detect such problem. Also, the funding bias, it's happening a lot. You are only funded, for example, by a tobacco company. What kind of result you will end up having? What do you think? I mean, if you are only getting your funding from a tobacco company, smoking company, selling cigarettes and so on, what will be your results? So if you are revealing or disclosing your sources of bias for funding, then by default people will know who is funding you, and when they know you are funded by whom, they will check and they will make sure if your work is biased or not. So the transparency here, or the disclosure, is very important. And finally, the conflict of interest. How to avoid the conflict of interest when I'm doing a research is to also disclose the partners of the project, especially for those confidential projects. The more the project is getting into the confidential mode and non-disclosure and secrecy word, misconduct find this is the best environment to grow and to mutually have mafiosi behaviors, and we will have all different interested and so on. So disclosure is so important. Disclose your partners. Disclose your funding authorities. Make sure that you share your data. Make sure that you have repetition of your data statistical tests. Make sure that you are involving different disciplines to assure the multidisciplinarity or the interdisciplinarity, and having different perspective to cover the topic. So this is the part of the bias. I want to move about another part which we just talked about, is the disclosure. So to avoid the bias in your research and to be labeled as a really objective scientist in your field and domain and to be respected by your peers, you need to make sure that you disclose as much as possible. It is not done in many institutions and journals, unfortunately. It does not prevent bias in research. Many people publish or disclose their data, but still they keep their work biased, and it requires enforcement and management. So in this sense, we are behind, but also it's very difficult to build a society that is built on mistrust. Like I told you in the beginning of the presentation, science should be built on trust and self-criticism and self-quality assurance. So it is something to be done at least in your lab or in your research group, or at least if you cannot do it, only for your own projects. So this is the only way to be credible and to have a good reputation. Now I want to talk about another conflict or another problem, which is the conflict of interest that we talked about. Conflict of interest is simply that you rely on your own self-reported data or your own publications. Prevalence of conflict of interest disclosure in research sponsored by industries, so that you do not mention who is sponsoring you. Influence of industry funding and other conflict of interest on outcomes and quality of systematic reviews. Maybe I'll go one step back. Why the point number 2 is so important? Because by default, when you are sponsored by a company, the company wants to sell product and services, while you are seeking to reveal the truth, to bring insights, understandings, discoveries, tools, mechanism, and so on. So the conflict of interest is here happening in which sense? There is 2 stakeholders, the scientist and the funding agency. The funder wants to make sure that the result that promotes their products are published, while the scientist should put everything equal and just publish their work, taking into account multiple criteria approach, having environmental, social, and economical criteria. And here comes the conflict. If the funding agency controls the scientist and the project, it will be very difficult to be objective. And here comes the conflict. Another important part of conflict of interest is that industry funding influence even sometimes systematic reviews. And as we mentioned before in the lecture on the experimental research, if you remember, we said that the highest level of confidence and truth in research is to do a systematic peer review based on randomized control trials. And whatever you will find in this systematic review that is based on reviewing a series of papers that conducted randomized control trials, this will be the highest confidence that we can get ever regarding any problem or any issue. So a lot of industries, they fund systematic reviews to promote specific findings that are beneficial for their sales, for their products, for their services. And here comes the conflict of interest again, but in a magnified way, and this is very dangerous. Also, peer review bias happens, and it's all over the place. It happens during the single blind, therefore we ask always we promote the double blind peer review. We promote also open peer review, so that we know who is the reviewer, what they are saying, because many reviewers, unfortunately, they abuse this trust and they are biased, and there is other systems of fighting this issue by doing mixing blinded with open peer reviewing, doing cascading, for example, and so on. But one of the most dangerous conflict of interest and biases that we witness in the scientific community, it happens also during the review, is the gender bias, the age bias, ethnic bias, religious bias, country bias, especially in peer review. And I can assure you that there is some countries by name, just because the authors, they have non-Latin names, they end up being rejected. Or sometimes some reviewers or some editors will just feel not confident, or because there is scandal in a specific country, or it's famous of having a scandal, they will in a biased way, judge the whole publishers from this country. So it happens. The bias will stay. This is very human, whether it is based on females or males. Also, this is a big issue, women and in publishing, in academia. But this is not the topic. Is all I have to say here is that you as a reviewer or as a responsible in any scientific position, if you have the authority to review somebody's work or project or for funding or for publication, you must make sure that you are not biased and you are not taking sides just because of your emotional brain or for subjectivity. Make sure that you are objective. Do not discriminate. You should not care about the gender, the age, the ethnicity, the religion, or the country of origin of the authors. And it's always preferable to not reveal this information so that the review is very biased. But unfortunately, we are human beings and it happens, and we should not forget that at the end, human beings are not strong in doing rational and taking rational decisions. Now, I want to end up this part of the presentation and move to another concept, which is the credibility and legal protection. It's very important to look at credibility and legal protection as a way, as a shield for you when you conduct research. You need to make sure that you are credible, meaning that you have a good reputation, people trust you, your promoter trust you if you are an undergrad or a postgrad, and if you are a scientist or a academic, you have to make sure that you are credible and that you are protected and not falling in mistakes. How to do that? One of the most common ways of to do that is something called pre-registering the research project. How does this work? It's simply laying out your hypothesis, methods, and analysis plan in writing before you collect any data. So you can do that as part of your research proposal, or you can have an appendix, or you can have a pre-registration, so you publish your whole methodology before conducting the research. By that, if any problem happens during your data collection or data processing or management, you can directly refer to this pre-registered document, and you can say, I had these steps already planned, and I am already sharing this information for transparency, for credibility, and I did not manipulate the data, I did not react during the way to benefit or manipulate the information. So this is a very common approach, and it brings credibility. It shows commitment to your specific research approach, and there's very common ways to publish your methodology before conducting your data collection or conducting your experiment. And to be honest, in my opinion, this is one of the highest and the most rigorous ways to make sure that you are credible. Also, you have to seek legal protection, and there are different types of legal protection worldwide. Legal protections are published by agencies who fund or commission research. The most famous documents is the European Code of Conduct, the European Union General Data Protection Regulation, GDPR, the Declaration of Helsinki for any human experimentation, the United States National Institutes of Health, the NIH, the Food and Drug Administration, the FDA, very famous, and the equivalent in Europe, the EMA, the European Medical Agency, I guess, the US Office of Research Integrity, and UK Research Integrity Code. And there is other different examples. I cannot stop listing them. I remember the Hong Kong and Stockholm, also the very famous one in Korea. So many countries, they have a legal protection that tells you how you perform data, how you conduct data, how you process it, how you manage it. And if you comply with these codes of conduct, you will be always protected, because you will be complying with these codes, and by default, you will not be looked in a way, suspicious way, regarding your research and your research outcomes. So simply, I advise you to contact your valorization officers at your institution and legal profession to determine the data, and determine your not only your data ownership, but also your legal protection framework. So it's very important, and I invite you, if you are in the European domain, to read download and read the European Code of Conduct for Research integrity. It's a very important reference document and has a lot of details, and you learn a lot about things you would never have thought about. Now I want to go into further detail. I mentioned the European Union General Data Protection Regulation. I just want to give you a glimpse about it because it's a very stringent rule that came into regulation in 2018, and it impacted a lot of researchers, and it's so important. So as you can see, this GDPR, or the General Data Protection Rule, puts into account many criteria. There is a full video if you want to go further into detail, but just to give you an idea, first of all, it makes sure that any subject or any work with humans as subject are protected. They have access. Individuals request access to their personal data. They can request the access to their personal data and ask how their data is used by the company after, or by the research team after it has been gathered. It allows the subject to be forgotten, which means that you can withdraw your consent from the lab or research group to use in personal data. The data portability, also you have the right to transfer the data if you are working with a provider. You need to be informed about any data collection. The consent is very important so that you can give it or not. You need to have information corrected if the data is personal. Also, it allows to restrict the processing so that the data cannot be used by third party or cannot be processed for other objectives. Also, the object needs to be clear. This includes the rights of individuals to stop the processing of their data for any direct marketing, and to be notified if there is any data breach within 72 hours. As you can see here, I talk sometimes about company and sometimes about the lab, because many research of observations happen in collaboration between companies or data collection companies and research lab. So many scientists will outsource the data collection process to data mining agencies or data collection agencies, and then you will have a very conflict, or a very sensitive conflict. You have the data collected by a private company, and then you have the data procured to be used by the scientist, but in the same time the company can use this data as a for third parties. So here the GDPR is very strict with these rules, and it's setting very straightforward guidelines. One of the most important one is the informed consent, is not passing the information to third party, and the ability to go back and retract the data registry or the data input. So the GDPR is very important, and you need to make sure that when you are conducting your research as part of the research ethics, that you comply with the GDPR requirements. If you don't know enough about the GDPR requirement, I advise you to have a look at my more detailed video. You need to have to prepare the compliance. By default, privacy is the number one. The subject is the king, and you need in this sense to map your project data, make sure what data I want to collect and use, determine what data do you need to keep after, because the GDPR does not allow you to keep the data on record unless you ask for consent, which is a big issue in the European Union, and you must put security measures in place. If this data is on a server or on a digital platform accessible through a cloud or whatever, you need to have security measures to make sure that there is no leakage. And if this data is physically stored in a place or in a building, you need to have a lock, you need to have to close it, it has to be armed, and you must make sure that there is no risk with stealing this data. So this is very important. Review your documentation, very important, and for sure establish procedures for handling any personal data. The GDPR is so sensitive with the use of observations or subjects in observations, collecting data. So all people who are doing observational research in general or qualitative research, they need to take into account these rules and comply as much as possible. So again, GDPR, if you are interested, further details, you find it in this video. Now I want to move to topic number 7, is the use of animals. I personally never use animals in my research. I don't have big research experience about it, but all I know is that as much as possible, avoid using the animals, because at the end you have suffering and you have long-term adverse effects. So the first thing to do is to avoid the use of animal. Now we cannot avoid it, because at the end, medical science and other science, psychological research and so on, they need to use animals. So there is procedures that need to be respected. You need to have a clear justification and special supervision on the scientists. So there must be somebody looking at the research group. Animal health and well-being must be maintained. You need to have trained and qualified researchers. Animal housing and procurement must be correct, and this involves the designed and conducted procurement. Scientific sound experiment. The experiment need to be scientifically sound. You need to minimize the discomfort, and you need anesthesia and pain relief as much as possible. Well, I just give you an example of the institutional control. Here is the Animal Care and Use Committee in the United States. It's a very famous committee, and this committee will ask to form a committee of trustees that will supervise the investigator or the principal investigator during his or her use of animals. And this is a very important one. So the principles or the best practices of replace the animals with other type of experiments, reduce the number of animals, refine and release the pain. These are all best practices, but the Institutional Animal Care and Use Committee in general in the United States must be conducted for any project, and the researchers will conduct the processes and will have different reviews to make sure that the use of animals is respecting best practices. Also, what you can be doing here is to pre-register the experiment and to publish your protocol with animal experimentation prior to conducting the experiments, as a sign of transparency, as a sign of respect to animals, and to a sign of integrity. Now I will move to point number 8, the use of human beings. We call them human subjects. And human subjects, these are, the use of human subjects require approval from institutional review boards. It's very important. Check university, check your national ethics committees, and make sure that you comply with their requirement. Number 1, human participants must give informed consent. This is very important. Informed consent is simply a form that has a briefing on the project with the objective, with the methodology, how much data will be collected, how much it will be stored, what is the purpose of the data, what will be the main variables that will be the study investigating and checking the variance in them, and you need the people to sign this document. So the informed consent needs to be done during the recruitment. It must include a briefing element, and it must comply with the GDPR if you are doing your research in any EU member state. If you are outside of the EU, you need to check the national laws of your own country. Also, it's very important that this informed consent is signed voluntary, no forcing, very neutral, no exercising of pressure. And if you cannot get enough number of people, here you need to exercise or check your innovation measures, make sure that there's a compensation, whether it's financial or any type of compensation, to make sure that people are convinced in a voluntary way to sign the informed consent and to give you this informed consent, because they need to know what is happening and how they are used as subject in your experiment, and that this experiment will not be abused, the data is protected, and so on, because people will never get involved in an experiment if they are feeling that the work is not respecting the research ethics and integrity, and it's not for a greater benefit for the humanity in general that this information or their participation is taken into account. Also, what is very important under this human subjects rule is to do no harm. During any work with human beings, do no harm, and the Protocol of Helsinki is very detailed about these rules, and I advise you to have a look at it. Be assured of the confidentiality. You are not allowed to share the data of the people, the personal information. Anonymity is a must, unless in your informed consent you are mentioning that the data will be revealed and that people are allowed to, or they give you the consent to share their personal information. But the default setting, like I told you, privacy is always the default setting, confidentiality, anonymity. Even if when you start to report, you are not allowed to point to a specific group of people, and so on and so on. So the GDPR Also regulation must be here respected and to make sure that anonymity and the confidentiality is respected. Another best practice when it comes to human subject is the privacy impact assessment. This is a list of best practice based on the International Association of Privacy Professionals, and actually privacy impact assessments can be taking place early on when you do your research. So it's a process which assists researchers in identifying and managing the privacy risk arising from new projects, initiatives, systems, processes, strategies, policies, research relationships. And it includes different steps. It provides an early warning system, a way to detect privacy problem, build safeguards before, not after, heavy investment, and to fix privacy problem sooner rather than later, avoid costly or embarrassing privacy mistakes, provides evidence that an organization attempted to prevent privacy risks, reduce the liability, negative publicity, damage of reputation, enhances the informed decision making. It helps also the organization to gain the public's trust and confidence, something that we talked about early on, and we said the importance of gaining the public trust because most of our research is funded by public taxpayers, demonstrating to employees, contractors, customers, citizens that the organization take privacy seriously. They have self or home developed protocols, they apply it, they know what are the best practices, they have learned lessons, they have case studies, and they are applying it, and they are informing and training their employees or their community. So these are some recommendations. Now, if you are in the worst case scenario, you must violate the informed consent. It's not me here who has to talk, it is your review boards. You need to go to your institutional review board and ask them, especially for people who are doing observational or behavioral studies, and you have to explain how you will conduct your research, why you will not get the informed consent, and in most of the cases the research must be scientifically significant. There is no other way. You have to explain to the committee that there is no other way to obtain the data, and that are minimal negative effect from the deceit or from the subject. So this is very important. And don't forget something, that if you get the approval from your institutional review board to violate the informed consent, you must debrief participant how they were misled after the experiment, especially if you have an experiment that has misleading information, or that you collected data without informing them. The people must know. But again, I'm not giving here any authority. It will be always your institutional review board that will give the green light or the black or the red light. So this is very important. Moving to the last misconduct that I want to talk about today, and one of the also emerging misconducts in the last 20 years, falsification and fabrication of data. Well, it is the falsification and fabrication of the data. It is the manipulation, creation, or misrepresentation of data, and it's a key ethical concern in academic world, an academic institution. It is intentional changes in the data to improve results or making data that was never collected. And here is an example of misconduct which happens in the fields of biomedical research. This is just an example. I don't want to stigmatize. The source is Nature and Monia Baker. And they analyzed here more than 20,000 biomedical papers, and they found that 4% of those papers contained inappropriately duplicated images. And you can see since the 1996, the study till 2014, it's significantly on the rise. So in order to avoid that, there are many journals that recruit super spotters of duplicated images in science papers. There is also plagiarism officers that are in different editorial review boards, journal boards, and there's also editors and screening officers. So all these people are working together to make sure that there is a fight and there is a scrutiny for this phenomena. So this is very important. Now from your side, what can we do if you are an editor, or if you are a reviewer, or if you are a promoter and you are not sure what should be done with this fabrication of data, first of all, check the information provided is meaningful and authentic. So does the findings at the end and the work make sense or not? So the high logic here is important. Research must keep in record, the researcher must keep in record the data available for 5 to 7 years so that other researchers can dig in and recheck and use the data set. And here comes when I talked about the bias section and the credibility, that it is always preferred to publish your data sets as if it's possible. And in this sense, those two guidelines can help you to start to, at least if you cannot detect it, you will control it on the long term. Because once you tell a scientist or a young researcher or even an experienced researcher that the data will be maintained for 5 to 7 years and it must be accessible, even if it's in a paper format or in a hard copy or a physical format, this will change their way and they will make them doubt or rethink if they are planning to falsify or fabricate an image. And also, as usual, the pre-registration of your research project, methodology, and publishing it before conducting your experiment, it will improve the disclosure and it will assure that most probably falsification and fabrication of result will not happen, because you're so honest and consistent with yourself that you decided even to write in detail your methodology, publish it, and adhere to it and not change it. So this is a very important sign. I think by that I ended today's presentation. I just want to go now to the conclusion. I try to wrap up, give some big important ideas that we discussed today, and give some takeaway message. So first of all, honesty and integrity is essential. So it needs to be taken into account during the reporting of your methods, during your data collection, and during writing your report and results. So it's very important to take it into account. Try to be as much as possible objective and try to learn to be objective and ask yourself always, am I biased? Am I objective enough? Avoid bias in any aspect of research, from experimental design to peer review to funding. You need to be diligent. Make sure that diligence is respected. Avoid careless mistakes. Critically review your own results and ensure that they are credible. You need to be open, share the data, share your results, share your data set, be open to new ideas and criticism, invest more in disclosures of your methodology, of your results, of your fundings, of your data set, and consider intellectual property as an important concept that needs to be maintained during the whole process and during the life cycle of the project, and make sure that your community is respecting the copyrights and patents. Never plagiarize or copy others' work, people's work. Another takeaway message that is very important for mentors: mentors should engage in discussions on research integrity. There must be a research culture in your institution about the integrity, about the research ethics, and about the research misconduct. It's very important. Also, it's very important to look at confidentiality, respect the guidelines on protection of sensitive information, comply with legal protection rules for like the GDPR for data protection. Animal care is very important. If you are going to use animals, make sure that they are necessarily and that the experiment will be well designed. Show respect for animals. When using human subjects, make sure that you protect them, make sure that they have privacy, minimize the risk, minimize the harm, and address the informed consent. Again, informed consent, informed consent. It's so important. Avoid conflict of interest. We talked about it, the funding, manipulation of the results, the biases, and so on. Stop industry-sponsored research. It's not a good thing as long the industry-sponsored research is not transparent and just a series of chain of confidentiality agreement. In this sense, avoid any industry-sponsored research that aims towards marketing purposes. Also provide disclosures to peer reviewers and comply with local and national ethics policies, rules, and guidelines. I just give you an example. There's a very nice project funded by the European Union. It's called Horizon 2020. It's called SOPS 4RI. It's the standard operation procedures for research integrity. I just yesterday, by chance, I got an email from this project organizer. They wanted to interview me. So don't hesitate to check their website, www.sops4ri.eu. It's a very interesting project, and I'm sure it will be bringing a lot of insight for European researchers and international researchers. Don't forget, we are in a very critical time, and we are in the digital age. There is a lot of algorithms that are detecting falsification and misconduct. So science is under scrutiny, and we need to be self-confident. And I'm not having here a call for complexifying the process of ethics. I'm just saying that researchers has to start on the ground level of researchers. So make sure that you invest in training of research integrity, research ethics culture, policy. It's better learned at an early age. And to be honest, I prefer always to talk about ethics in a culture rather than ethics on an individual level, because actually the culture and the community is the carrier of the values. So this is the best way to make sure that the values are practiced and they are really adopted by people. Invest in self-governance and data management. It's a big issue. Invest in it. You need to have a database management system. You need to check if your data will be in a hard copy or a soft format. Breaches, you know, cyber attacks are today all over the place. So this is very important. The governance of the data, the ownership of the data, the management of the data, because data sets are the future, and they are the gold mine that will keep you on track. So invest in the governance. Also embrace your mistakes and protect your reputation. Try, if you do anything, you find it erroneous or you have an error, whether you are conscious or not conscious, corrigendum, retractions. You can retract your own work if you feel this is not okay, something was wrong, or your foundations or your hypotheses were wrong. Retract it. This paper will not change anything. It's difficult to say this in early career, but when you are in a midlife or in the experienced life of scientific work as a scientist, it is not so difficult. It's not so difficult. Correct your own work with errata, addenda, corrigendum, and retract your own work. Act quickly, very important. If you have any breach of information, if you collected data, personal data from observation about human beings, and this data is violated, your hard disk got stolen, your computer got stolen, your cloud is attacked, and there is a breach of passwords, directly you must get contact with the people and tell them what happened. They must within 72 hours know what happened, and that their information, that maybe they trusted you and they gave you their information and their informed consent, they must be contacted. And also another one, blow the whistle if you find something is going wrong on the level of your group, department, faculty, laboratory, research center, and there is no understanding, and there is a conflict between the violation of the research integrity and what you are, the values you have. Maybe get a second opinion from somebody outside the institution, somebody you trust, somebody who has an experience. And if the whistle needs to be blown, blow the whistle. Just blow the whistle. We are in the time that we do not need to tolerate any violation or any misconduct in research. For sure, you don't need to be the guardian of the galaxy. You're not going to solve everything in the world. But if something in your domain and in your area of control and operation is not going right, you must blow the whistle if it is a misconduct. And finally, the last remark of today, be honest and be consistent, and definitely you will make mistakes. Just embrace them. It is part of the game, but reduce them, invest in the culture of research ethics and integrity, and definitely you will do a good job. By that, I would like to thank you everyone. Don't forget, this video on research ethics was part of the academic modules. There's other videos related to ethics. There's another video on the GDPR in detail. Don't hesitate to look at the video. And finally, if you find this video beneficial, like it, subscribe to my channel. I need the subscriptions to continue doing these videos, and for sure share it with the maximum number of people. Thank you very much, and I wish you all the best of luck with your research. Thank you very much.